Alright, so in this video we're going to talk about logarithm derivatives. So we'll start by considering the slopes of the natural log. Alright, so I'll bring in a picture here of the natural log. And we're going to look at the slope at 1 to start with. So let me draw a little tangent line here. And if you look at the rise over run, we go about over 4 little boxes and up 4 little boxes. So the slope here is 1. The slope appears to be approximately 1. Let's go to 2 here. So if we look at this little slope here, we go over about 4 boxes and we go up 2 boxes. So the slope here is around a half, approximately 1/2. Now we'll go to 3. If we look at this slope, we go over about 3 boxes and up about 1. So the slope is approximately 1/3. Okay, so at 1 it's around 1, at 2 it's around a half, and at 3 it's around a third. All right, so let's make a hypothesis. Let's claim that the derivative of the natural log of x is 1 over x. In other words, the slope of this function at different x values is 1 over that x value. All right, so now we're going to prove this, and this proof is a little bit technical, but we'll see in this proof why this claim turns out to be true. Okay, so in this proof we're going to use a definition. We're going to use the definition of E. E is the limit as k goes to 0 of 1 plus k all to the power 1 over k. So that will come in into the proof. All right, so let's take the derivative of the natural log by applying the limit definition. So the limit definition is h goes to 0 of the function with x plus h in it minus the function with x in it all over h. And our function is natural log. We're taking the derivative of natural log, so this is going to be the limit as h goes to 0 of the natural log of x plus h minus the natural log of x all over h. Okay, so now let's use a property of logs to combine the logarithms in the numerator. I'm also going to take this dividing by h and write it as multiplying by h. So I'll have 1 over h times this difference, and then this difference I can rewrite as the natural log of x plus h over x. Property that I'm using here is that the natural log of a over b equals the natural log of a minus the natural log of b, just reversing that property. Okay, and now I'm going to simplify the inside of the log, and I'm also going to introduce an x. So I'm going to divide by x and multiply by x. And I'm going to write the inside of the natural log as 1 plus h over x. Okay, so all I'm doing in this first part when I'm introducing the x is I'm multiplying by a fancy form of 1. Doesn't change the expression. The 1 that I'm multiplying by is just x over x, or 1 over x times x. And the second thing I'm doing is I'm just writing x plus h over x as x over x plus h over x, which is 1 plus h over x. Okay, so now I'm going to use another property of logarithms. Let's go down here. And that property is going to be, I can take a constant in front of the log and make it the power. So I can rewrite this as 1 over x times natural log of 1 plus h over x all to the h over x power. So this stuff over here looks a lot like e. This stuff over here looks a lot like e. In fact, if we make k equal to h over x, as h goes to 0, k is going to go to 0. So I can rewrite this limit as k goes to 0 of 1 over x natural log of 1 plus k, and then this x over h is the reciprocal of k. So 1 over k is x over h, and my power becomes 1 over k. All right, and that is e. 1 plus k to the 1 over k as k goes to 0 becomes e. So this is going to be 1 over x natural log of limit as k goes to 0 of 1 plus k to the 1 over k. That all turns into e, so we'll have 1 over x natural log of e, which is just 1 over x. And I'm done with my proof. Okay, so I want to do one more thing here. I want to find the formula for the derivative of log base a of x using the change of base formula. Okay, so let me remind you the change of base formula. So I'm going to take the derivative of this log base a of x, and the change of base formula says that the log base a of x is the natural log of x over the natural log of a. And we know the derivative of the natural log. The derivative of the natural log is 1 over x. Now this a natural log of a may look like a function. It's actually just a constant, so I can rewrite it, this quotient, as 1 over the natural log of a times the natural log of x. And this is just a constant. So when I take the derivative, it can be ignored. I'm just taking the derivative of the natural log. Okay, so I'll have 1 over natural log of a times the derivative of the natural log, which is 1 over x. So I get 1 over natural log of a times 1 over x, which we typically write as 1 over x natural log of a. All right, so let's just summarize this formula here. So derivative of log base a of x is 1 over x natural log of a. And the derivative of the natural log of x is just 1 over x. All right, I hope you found this video on the derivatives of logarithms useful.